Hello, and welcome to ThinkSleep, where we let curiosity move slowly and wonder doesn't need to rush. Tonight, we're following a thread that connects melting ice caps to ancient flood myths, magnetic field reversals to the fall of civilizations, a 12,000-year cycle that keeps appearing in places it shouldn't. Not as conspiracy, but as pattern. Not as certainty, but as whisper. What if Earth resets civilization every 12,000 years? Before we go any further, I'd love to know where you're listening from right now and what time it is where you are. It's a small thing, but it connects us across distance and dark. If you find this kind of slow exploration calming, if questions like this help you unwind, I'd be grateful if you considered subscribing or leaving a like. And if you feel moved to, drop a comment telling me where in the world you are. No pressure, just an invitation to be part of this quiet community of wandering minds. Now settle in, let your breathing slow, because what we're about to explore isn't written in history books. It's written in layers of ash, in stories older than empires, in the sudden disappearance of species and the equally sudden appearance of new ways of being human. The pattern is there. Whether it means what some think it means, well, that's what we're here to explore together. So let's begin where all good questions begin, not with answers, but with noticing. There's a number that keeps appearing, not in prophecy or fiction, but in data, in the layers of ice pulled from Greenland and Antarctica, in the pollen trapped in ancient lake beds, in the sudden shifts recorded in ocean sediment, and the collapse of climates that seemed stable. Every 12,000 years or so, something happens. Not always the same something, but something significant enough to leave a mark, a boundary, a before and after. The last ice age ended roughly 11,700 years ago. That's when glaciers that covered half of North America and much of Europe began their final retreat. That's when sea levels rose hundreds of feet, drowning coastlines and river valleys. That's when the climate stabilized into the warm, predictable pattern that allowed humans to stop wandering and start planting, to build villages, then cities, then civilizations. Everything we call history, everything we call progress, happened in this narrow window of time. This 12,000-year stretch of relative calm. But what if that calm isn't permanent? What if it's just a phase, a breath between events? And what if this pattern, this cycle, has happened before? We tend to think of the Earth as stable. The ground beneath us feels solid. The seasons follow a rhythm, the sun rises and sets, but that stability is recent and in geological terms unusual. For most of Earth's existence, the climate has been wildly unstable. Ice ages have come and gone, oceans have risen and fallen, continents have drifted and collided. And life, tenacious as it is, has adapted or perished depending on the speed and scale of the change. Humans, modern humans, have only been around for about 300,000 years, and for most of that time we lived in small groups, moving with the seasons, hunting and gathering, leaving almost no trace. We didn't build monuments, we didn't write things down, we passed knowledge through story and skill, and when people died, much of what they knew died with them. It wasn't until the end of the last ice age, until that 12,000-year mark, that something shifted. Suddenly, or so it seems from our perspective, humans started settling, started farming, started creating systems complex enough to require coordination, trade, and record keeping. Why then? Why not 50,000 years ago or 200,000? Was it just that we finally got smart enough? Or was it that the world finally became stable enough to allow it? And if stability was the key, what happens when stability ends? This isn't a new question. Archaeologists and climatologists have been circling it for decades, but it's not a comfortable one, because it implies that the foundation we've built our entire civilization on might be temporary, that the window we're living in might close, that resets, if that's what they are, might be built into the system. And the more you look, the more the number appears. Roughly 12,000 years ago, the Younger Dryas, a sudden return to Ice Age conditions, ended as abruptly as it began. Roughly 24,000 years ago, the last glacial maximum when ice sheets reached their furthest extent. Roughly 36,000 years ago, another climate boundary. The pattern isn't perfect, the intervals aren't exact, but they're close enough to make you pause, close enough to wonder if coincidence is doing more work than it should. Because Earth doesn't operate on human time, it operates on orbital mechanics, on magnetic rhythms, on the slow churn of tectonic plates and the patient accumulation of ice. And some of those rhythms, it turns out, fall into cycles, cycles that intersect, cycles that amplify each other, and sometimes when enough cycles align, the result is dramatic. A tipping point, a cascade, a reset. The question isn't whether Earth changes, it does constantly. The question is whether those changes follow a pattern, and whether that pattern has consequences for anything complex and fragile enough to be called civilization. Not just human civilization, but any civilization. Anything built on the assumption that tomorrow will resemble today. We don't have all the evidence. We may never have it. But we have enough to ask the question seriously. Enough to explore what it might mean, enough to sit with the discomfort of not knowing. And maybe that's the point. Not to find a final answer, but to look closely at the ground we're standing on and realize how much of it is still mystery. So tonight, we're going to walk through that mystery together, slowly, gently. We're going to look at ice and stone and star and bone. We're going to consider what might trigger a reset, what the evidence suggests, and what it might mean for us now. We're not going to arrive at certainty, but we might arrive at something better. A kind of informed wonder, a recognition that the universe is larger and stranger than our daily experience suggests, and that our place in it is both smaller and more precious than we usually allow ourselves to feel. And if somewhere along the way your thoughts begin to drift, if your breathing deepens and the words start to blur, that's not a failure. That's the point. Because sleep too is a kind of reset, a nightly return to something essential. And maybe in learning to rest with uncertainty, we learn something about how to live with it too. So let's continue, but slower now, into the question of time itself. When we think about the past, we usually think in human lifetimes. A century feels long, a millennium feels ancient. We look at the pyramids of Egypt, built around 4,500 years ago, and they feel impossibly old. We look at cave paintings from 30,000 years ago, and they seem like messages from another world. And in a sense, they are. The people who made them lived in a world so different from ours that we can barely imagine it. Ice still covered much of the northern hemisphere. Mammoths and saber-toothed cats still roamed. The coastlines were hundreds of miles from where they are now, because so much water was locked up in glaciers. But even that, even 30,000 years, is nothing in geological terms. It's a thin layer, a recent development, a single page near the very end of a very long book. Earth is approximately 4.54 billion years old. That number is hard to hold in your mind because it's so far outside human experience. We don't have an intuitive sense of a billion of anything, let alone a billion years. So let's try a different approach. If we compressed Earth's entire history into a single 24-hour day, modern humans wouldn't appear until the last few seconds before midnight. All of recorded history, everything from the first cities to the moon landing, would fit into the final fraction of the final second. We are so recent that we barely register on the planetary timeline, and yet we've convinced ourselves that we understand the planet, that we know what's normal and what's not, that the climate we've experienced, the stability we've enjoyed, is the default state. But it isn't. For most of Earth's history, the planet has been either much hotter or much colder than it is now. There have been periods where ice reached the equator, periods where there was no ice anywhere, periods where the atmosphere was toxic to anything that breathes oxygen, periods of suffocating heat, and periods of deep freeze. The current climate, the one we call normal, is actually unusual. We're living in what's called an interglacial period, a warm phase between ice ages, and interglacial periods don't last forever. The pattern over the last 2 million years has been pretty consistent. Ice ages lasting tens of thousands of years, interrupted by brief warm periods lasting 10 to 15,000 years. Then the ice returns. We're currently about 11,700 years into our warm period, which means if the pattern holds, we might be closer to the end than the beginning. Now, that doesn't mean glaciers are going to start advancing next year or even next century. Geological processes move slowly, and human activity has complicated the picture in ways we're still trying to understand. But it does mean that the stability we've come to expect is not guaranteed. It's contingent. It depends on factors much larger than us, and some of those factors operate on cycles we didn't even know existed until very recently. Agriculture, the foundation of civilization, only became possible about 12,000 years ago. Before that, humans tried. There's evidence of people gathering seeds, cultivating wild grains, experimenting with horticulture. But it didn't take hold. The climate was too unstable. Growing seasons were unpredictable. A hard frost could wipe out an entire crop. And if you'd invested months of labor into planting and tending, that was catastrophic. So people stayed mobile. They followed the herds and the seasons. They kept their options open. Then, around 11,700 years ago, something changed. The climate stabilized. Temperatures evened out. Rain became more predictable. And suddenly, or at least relatively suddenly, humans all over the world began to settle. In the Fertile Crescent, in China, in Mesoamerica, in the Andes. Independently, without contact, people in different parts of the world started planting crops and building permanent homes, not because they suddenly got smarter, but because the world finally allowed it. That moment, that shift, is what we call the Neolithic Revolution. It's the hinge point between prehistory and history. Everything we think of as civilization, cities, writing, art, science, government, all of it flows from that one transition, and that transition was made possible by climate stability. So the question becomes, what happens if that stability ends? Not in some distant future, but within the rhythm that seems to govern these shifts. What happens at the next 12,000-year mark, or the one after that? We know from ice cores that the climate can change fast, not over centuries, but over decades, sometimes over years. The Younger Dryas, which we'll talk about more later, saw temperatures in the Northern Hemisphere drop by as much as 15 degrees Celsius in less than a decade. That's not a gradual cooling, that's a collapse. And when it ended, the warming was just as abrupt. Within 50 years, the world went from Ice Age conditions back to something close to what we experience now. If that happened today, civilization wouldn't adapt, it would fracture. Agriculture depends on predictable growing zones. Cities depend on stable water supplies. Supply chains depend on infrastructure that assumes certain routes will remain passable. A sudden climate shift wouldn't just be uncomfortable, it would be destabilizing on a scale we have no reference for. And here's the thing, the geological record suggests this has happened before, not once, but repeatedly. Every time the ice retreats, every time an interglacial period begins, there's a window of stability. And then something shifts, sometimes gradually, sometimes suddenly, and the ice returns, or the climate lurches in another direction, and whatever was built during the stable period gets buried, drowned, or abandoned. We have no written records from before 5,000 years ago. We have fragments, artifacts, ruins, but we don't have continuous history. We don't know what was tried and lost before the civilizations we do know about. We don't know how many times humans might have started to build something complex, only to have it collapse when the climate shifted. The assumption has always been that prehistoric humans were too primitive to build anything worth remembering, that they were just tribes and bands, scraping by, waiting for the right moment to evolve into something greater. But what if that's wrong? What if they were just as clever, just as creative, just as capable, but the world kept resetting before their efforts could compound? This isn't about lost cities or ancient high technology. It's about something simpler and sadder. The possibility that progress isn't linear, that civilizations don't just rise and keep rising, that the ground beneath them can shift, and when it does, everything built on that ground becomes archaeology. We think of ourselves as the culmination of history, the inheritors of everything that came before. But maybe we're just the latest attempt, the most recent experiment in what's possible during a warm phase, and maybe, if this cycle continues, we're not the last. That's not a comfortable thought. But comfort isn't the goal here. Understanding is. And part of understanding is recognizing how brief and fragile this moment is. Not to despair, but to appreciate, to see the 12,000 years we've had not as inevitable, but as a gift, a window, a chance, and to wonder, with quiet seriousness, what happens when the window closes. So where does the cycle come from? If Earth resets every 12,000 years or so, what's driving it? Is it random? Or is there a mechanism, something predictable buried in the way the planet moves through space? The answer, it turns out, is both simpler and more complex than you might expect. And it starts not with Earth, but with its relationship to the Sun. Earth's orbit isn't a perfect circle, it's an ellipse, and that ellipse changes shape over time. Sometimes it's more circular, sometimes more elongated. This cycle takes about 100,000 years to complete. At the same time, Earth's axis, the invisible line it spins around, isn't fixed. It wobbles, like a spinning top that's starting to slow down. This wobble, called precession, takes about 26,000 years to complete a full cycle. And the tilt of that axis, the angle at which Earth leans relative to the Sun, also shifts. Sometimes the tilt is more pronounced, sometimes less. This cycle takes about 41,000 years. These three cycles, orbital eccentricity, axial precession, and obliquity, are called Milankovitch cycles, named after the Serbian scientist Milutin Milankovic, who figured out their connection to ice ages in the early 20th century. Individually, these cycles change how much solar energy different parts of Earth receive at different times of year. And when they align in certain ways, the effects amplify. Summers get cooler, winters get longer. Snow that falls in winter doesn't fully melt in summer. It accumulates, year after year, layer after layer, until it compresses into ice. And once enough ice forms, it reflects sunlight back into space, cooling the planet further. The ice feeds itself. This is how ice ages begin. not suddenly, but through a slow feedback loop triggered by orbital mechanics. And the reverse is also true. When the cycles shift in the other direction, when summers get warmer and winters get shorter, the ice begins to melt, sea levels rise, the climate warms, and life, patient and opportunistic, expands into the newly available land. The Milankovitch cycles explain the big pattern, the march of ice ages over hundreds of thousands of years. But they don't explain everything. They don't explain why, within those larger cycles, there are sudden jumps, rapid shifts that happen far faster than orbital mechanics alone would predict, and they don't fully explain the 12,000-year rhythm. Because overlaid on top of the big cycles are smaller ones, faster oscillations, and some of those seem to cluster around the 10,000 to 13,000 year range. Not perfectly, not like clockwork, but often enough to notice. One of the most dramatic examples is the Younger Dryas. About 12,800 years ago, Earth was warming, the ice sheets were retreating, the climate was stabilizing, and then, without warning, everything reversed. Temperatures plunged. Glaciers that had been melting began to advance again. In Greenland, temperatures dropped by an estimated 15 degrees Celsius in less than a decade. In Europe, forests died back, lakes froze, animal populations collapsed, and humans, who'd been expanding into newly available territory, suddenly found themselves in a world that had turned hostile again. This cold snap lasted for about 300 years. Then, just as abruptly, it ended. Around 11,700 years ago, temperatures shot back up. Within a few decades, maybe less, the climate returned to interglacial warmth. The ice retreated again, and this time, it stayed retreated. This is the warming that allowed civilization to begin. But what caused the Younger Dryas? What could reverse a warming trend so quickly and then reverse the reversal just as fast? Milankovitch cycles can't do that. They're too slow. Something else had to be involved. Something sudden. There are several theories. One involves ocean currents. The Atlantic meridional overturning circulation, which includes the Gulf Stream, is driven by differences in temperature and salinity. Warm, salty water flows north from the tropics, releasing heat into the atmosphere as it goes. When it reaches the Arctic, it cools, becomes denser, and sinks, pulling more warm water behind it. It's a conveyor belt, and it keeps the North Atlantic and much of Europe much warmer than they would otherwise be. But what if that conveyor belt shut down? What if a massive pulse of fresh water, from melting glaciers or the sudden draining of a glacial lake, poured into the North Atlantic, diluting the salty water and preventing it from sinking? The conveyor would stall. Warm water would stop flowing north, and the climate, especially in the northern hemisphere, would crash. There's evidence that this happened. Sediment cores from the North Atlantic show a layer of ice-rafted debris dating to the start of the Younger Dryas, suggesting a massive discharge of icebergs. And there are signs of a catastrophic flood from Lake Agassiz, a huge glacial lake that formed behind the retreating ice sheets in what's now central Canada. If that lake drained suddenly, it would have been enough fresh water to disrupt the entire Atlantic circulation. So that's one explanation, a plausible one, but it's not the only one, and it doesn't explain everything. It doesn't explain why the pattern seems to repeat, why there are other boundaries in the geological record, other moments of abrupt change that don't all line up perfectly with glacial lake outbursts but do line up with something else. Some researchers have started looking at other factors. Solar activity, for instance. The sun isn't constant. Its output varies on multiple timescales. The most famous is the 11-year sunspot cycle, but there are longer cycles too. periods of increased activity and periods of quiet. And during periods of solar minimum, when the sun is less active, Earth receives slightly less energy. Not much, but in a system as finely balanced as climate, small changes can have large effects. There's also the question of cosmic rays. When the sun is quiet, its magnetic field weakens, and more cosmic rays from deep space reach Earth's atmosphere. These rays can seed cloud formation, increasing cloud cover, which reflects more sunlight, which cools the planet. It's a subtle effect, and scientists are still debating how significant it is, but it exists. And then there are the cycles we don't fully understand yet. Patterns in volcanic activity, fluctuations in Earth's magnetic field, the complex interactions between ice sheets, ocean currents, atmospheric circulation, and the biosphere. Each of these systems has its own rhythms, and when they sync up, when multiple cycles peak or trough at the same time, the effects can be dramatic. The point is, Earth doesn't change randomly. It changes according to rhythms. Some of those rhythms are well understood, others are still being mapped. But the more we look, the more we find patterns, and one of those patterns hovers around the 12,000-year mark. Not every 12,000 years exactly. Not like a metronome, but often enough that it stops feeling like coincidence and starts feeling like a signal, a pulse, a rhythm in the system that, when it hits, reshapes the surface of the world. And if that rhythm is real, if it's built into the mechanics of how Earth interacts with the sun and the cosmos, then it's not a question of if it will happen again. It's a question of when, and whether we're anywhere close. We can't know for certain. We don't have enough data. We don't have a complete model of all the factors involved. But we can look at where we are in the cycles we do understand. And what we see is this. We're 11,700 years into the current interglacial. We're in a period of relatively low solar activity. Earth's magnetic field is weakening. The ice sheets, though diminished, are still melting, pumping fresh water into the oceans. And the climate, despite or because of human influence, is behaving in ways that don't fit the models we built, based on the last few centuries of relatively stable conditions. None of that proves a reset is imminent. But it does suggest that the conditions that have allowed civilization to thrive are not permanent, that the cycles are still turning, and that nature doesn't care about our plans. So we watch, we measure, we try to understand, and we sit with the quiet knowledge that the ground we stand on is part of a system much larger and older than us, a system that has its own rhythms, its own way of renewing itself. And maybe that's not something to fear. Maybe it's just something to recognize. The Earth doesn't reset to punish or destroy. It resets because that's what complex systems do. They oscillate. They find new equilibria. They move through cycles of growth and collapse and renewal. We just happen to be living in one phase of one cycle. And if we're lucky, if we pay attention, we might learn to see the beauty in that. The privilege of being here, now, in this brief, warm window. Before the next turn of the wheel, there's something we don't think about often enough. Ice has weight, not just the weight of a few snowflakes or an ice cube in a glass, but the crushing, incomprehensible weight of entire continents covered in frozen water, miles thick, pressing down on the crust of the Earth with a force that bends stone. During the last ice age, ice sheets covered Canada, the northern United States, Scandinavia, and much of northern Europe and Asia. The Laurentide ice sheet over North America was more than 2 miles thick in places. That's not a metaphor. 2 miles of solid ice, stacked up, bearing down on the land beneath it. And that weight does something. It pushes the crust down into the softer mantle below, like pressing your thumb into clay. The land sinks, sometimes by hundreds of meters, and it stays sunken as long as the ice remains. But when the ice melts, when those trillions of tons of pressure suddenly lift, the land doesn't just spring back, it rebounds. Slowly, over thousands of years, the crust rises again, like a cushion regaining its shape after you stand up. This process is called isostatic rebound, and it's still happening today in places like Scandinavia and Canada. The land is still rising, still recovering from the weight it carried 12,000 years ago. But that rebound isn't gentle or isolated. When the crust moves, when continents rise or tilt, it affects everything else. Fault lines shift. Pressure that's been building underground finds new pathways to release. Volcanoes that were suppressed under the weight of ice suddenly lose that pressure, and magma that had been waiting rises. This isn't speculation. We have evidence of increased volcanic activity following deglaciation. In Iceland, in the Pacific Northwest, in the Andes, volcanic eruptions surged after the ice melted. The planet was adjusting to a new configuration, and it's not just volcanoes. Earthquakes increase too. As the crust flexes and rebounds, old faults slip. New ones form. The entire tectonic system recalibrates. Studies of seismic records and geological layers show clear spikes in earthquake activity during periods of rapid ice melt. The Earth, in a very real sense, becomes unstable. Now imagine that process happening not slowly over millennia, but quickly. Imagine an ice sheet collapsing faster than expected, dumping its weight into the ocean in a matter of centuries or decades. The land beneath would rebound faster, the strain on the crust would increase, and the likelihood of triggering cascading geological events, earthquakes leading to landslides, leading to tsunamis, leading to volcanic eruptions, would rise dramatically. This is part of what makes the 12,000-year cycle so potentially significant, because it's not just about climate. It's about the physical structure of the planet. Ice ages don't just freeze things, they compress them. They hold the crust in place. And when the ice releases, the planet shifts. It reorganizes itself. And during that reorganization, everything becomes more volatile. Sea levels rise, but not evenly. Different parts of the ocean rise at different rates depending on gravitational effects from the remaining ice, on currents, on the shape of the ocean floor. Coastlines that were stable for thousands of years vanish underwater in generations. River systems change course. Lakes drain or form. Islands disappear. New ones emerge. And then there's the water itself. When ice melts, it doesn't just raise the ocean. It fills rivers, overfills lakes, creates temporary seas in low-lying areas. Some of these glacial lakes were enormous. Lake Agassiz, which we mentioned earlier, covered an area larger than all the current Great Lakes combined, and it was held back by nothing more than an ice dam. When that dam failed, as ice dams eventually do, the water didn't drain slowly. It exploded outward. Some estimates suggest the flow rate during the catastrophic drainage of Lake Agassiz was greater than the combined flow of all the rivers on Earth today. Imagine that. A wall of water so vast it reshaped landscapes in hours. And this didn't happen once. It happened multiple times as the ice sheets melted and reformed and melted again. Each time, the sudden influx of fresh water disrupted ocean circulation, altered salinity, changed weather patterns. Each time, the world downstream had to absorb the impact. For anything living in that world, for any group trying to establish a foothold, build a settlement, develop a way of life, these events would be catastrophic. Not just locally, but globally. A flood in one region could trigger climate changes everywhere. A volcanic eruption in another could dim the sun for years. An earthquake could shatter trade routes and isolate populations. This is what a reset looks like from the inside. Not a single event, but a cascade. A series of disruptions that compound, that overwhelm the ability of systems, natural or human, to adapt. And the trigger, more often than not, is the melting of ice, the release of pressure, the planet shifting from one equilibrium to another. We're watching something similar now, though the causes are different. The Greenland and Antarctic ice sheets are losing mass. Not as fast as during the end of the last ice age, not yet, but faster than they were a century ago. And as they melt, as that weight lifts, the land beneath is beginning to rise, slowly for now. But the process has begun, and with it, the possibility of instability. Not tomorrow, not next year, but on the timescale that geology operates on. The timescale where 12,000 years is recent. Where patterns repeat not because someone planned them, but because the physics of ice and stone and pressure don't change. The weight of ice shapes the world, and when that weight is removed, the world reshapes itself, sometimes gently, sometimes not. And if the cycle is real, if the rhythm holds, then every time we pass through a deglaciation period, every time the ice melts and the land rebounds, we enter a window of heightened risk, a period where the planet is in flux, where the rules that governed the previous era no longer apply, and maybe that's when civilizations fail. Not because they did something wrong, but because the ground beneath them stopped being solid, because the climate stopped being predictable, because the systems they depended on, the rivers and coasts and growing seasons, all changed at once. The ice doesn't care what we've built. It melts when conditions allow, and when it does, the planet adjusts. We're just along for the ride. There's something invisible protecting us right now, something we can't see or touch, but that shields us from radiation streaming across space at nearly the speed of light. It's Earth's magnetic field, a bubble of magnetism generated deep in the planet's core, where liquid iron churns and flows in patterns we still don't fully understand. This field extends thousands of miles into space, deflecting solar wind and cosmic rays, creating the conditions that allow life as we know it to exist on the surface. Without it, our atmosphere would slowly be stripped away, the way Mars lost most of its atmosphere billions of years ago. Without it, radiation levels at the surface would be lethal. Without it, there would be no auroras, no compass needles pointing north, no migrations guided by magnetic sensing. It's so fundamental to the way Earth works that we rarely think about it, but we should, because the magnetic field isn't stable. It shifts, it weakens, and every few 100,000 years it flips completely. A magnetic reversal is exactly what it sounds like. North becomes south, south becomes north. Compasses that pointed one direction suddenly point the other. But the transition isn't instant. It's not like flipping a switch. The field doesn't just reverse. It weakens first, sometimes dramatically, falling to a fraction of its normal strength. During that weakening, the poles can wander. Multiple poles can appear and disappear. The field becomes chaotic. And during that chaos, which can last hundreds or even thousands of years, Earth's protection against radiation diminishes. We know this happens because the evidence is baked into rocks. When lava cools, minerals within it align with the magnetic field at the time, like tiny compass needles frozen in stone. By studying layers of volcanic rock from different periods, scientists can read the history of Earth's magnetic field going back hundreds of millions of years, And what they've found is a pattern of reversals, not regular, not predictable in the short term, but consistent over geological time. The last full reversal happened about 780,000 years ago. We're overdue, statistically speaking, though that doesn't mean much when the average interval between reversals is 500,000 years. But here's where it gets interesting. There's evidence that the field doesn't just reverse. It also experiences shorter periods of instability, periods where it weakens significantly without fully flipping. These are called excursions, and they can happen on much shorter timescales, thousands of years instead of hundreds of thousands. And some of these excursions seem to cluster around certain time periods, including around 12,000 years ago. The Lachant excursion, one of the most studied, occurred about 41,000 years ago. During this event, the magnetic field weakened to about 25% of its current strength. The poles wandered wildly, and for a period of several centuries, Earth's protection against cosmic radiation dropped significantly. Studies of ice cores and tree rings from that period show increased levels of isotopes produced when cosmic rays strike the atmosphere. The planet was being bombarded. What would that do to life? It's hard to say with certainty. Some researchers have suggested it could have contributed to the extinction of Neanderthals or other megafauna. Others think the effects would have been more subtle, increased mutation rates, disrupted animal migrations, auroras visible at the equator. But even subtle effects can matter if they persist long enough or coincide with other stressors, and we're not just talking about ancient history. Earth's magnetic field is weakening right now. It's lost about 9% of its strength over the past 200 years. In some regions, particularly over the South Atlantic, the field is so weak that satellites passing through that area experience increased radiation damage. It's called the South Atlantic anomaly, and it's growing. The magnetic North Pole is also moving, faster than it has in recorded history. It's currently drifting from Canada towards Siberia at about 30 miles per year. Does this mean we're heading toward a reversal or an excursion? We don't know. Magnetic field behavior is notoriously difficult to predict. The processes that generate it, deep in the outer core, are chaotic and nonlinear. Small changes in flow patterns down there can have large effects up here. And we can't exactly send probes to the core to measure what's happening. We can only infer from what we observe at the surface. But the timing is curious. We're roughly 12,000 years past the end of the last ice age. We're in a period of rapid environmental change. And the magnetic field, which has been relatively stable for the last several thousand years, is now showing signs of instability. Could these things be connected? Could the shifting weight of ice, the rebounding crust, the redistribution of mass on the planet's surface somehow affect the flow of liquid iron in the core? It sounds far-fetched, but it's not impossible. The core and the mantle and the crust are all part of one system. They interact. Changes in one layer can propagate to others, though usually on very long timescales. And there is some evidence, tentative and debated, that periods of rapid climate change and deglaciation correlate with increased magnetic field variability. The mechanism isn't clear, but the correlation exists. What we do know is that a weakening magnetic field has consequences. More cosmic rays reach the lower atmosphere, potentially affecting cloud formation and, by extension, climate. Electronics become more vulnerable to solar storms. Navigation systems that rely on precise magnetic measurements become less reliable, and if the field weakens enough, if we enter a true excursion or reversal, the effects could be widespread, not apocalyptic but disruptive. Another layer of instability added to an already unstable period. And if this has happened before, If magnetic excursions align with other cyclical changes around the 12,000-year mark, then it's another piece of the pattern. Another factor that might contribute to the kinds of rapid cascading changes that could reset a civilization. Not by destroying it outright, but by undermining the stability it depends on. By making navigation harder, communication less reliable, agriculture more vulnerable to cosmic radiation, and the climate even more unpredictable. The magnetic field is one of those background systems we take for granted until it changes, like the climate, like the crust beneath our feet. And when multiple background systems change at once, when the cycles align, the result is a world that feels suddenly unfamiliar, where the old rules don't apply, where what worked yesterday might not work tomorrow. We're not there yet, but we're watching, measuring, trying to understand the rhythms of the invisible shield that protects us, and hoping that when the next shift comes, whenever that is, we're prepared, or at least aware. Because the magnetic field, like ice, like the planet itself, doesn't care what we've built. It follows its own rhythms, and we, for all our technology, are still dependent on it, still at the mercy of forces we didn't create and can't control. But we can observe, we can learn, and we can sit with the knowledge that the universe is more dynamic, more alive than we usually give it credit for. Even the things we think of as solid and permanent are shifting, always have been, always will be. And maybe that's okay. Maybe that's just what it means to live on a planet that's still very much in motion. We tend to think of space as empty, a vast nothing between here and there, but it's not empty at all. It's full of debris, dust and ice and rock left over from the formation of the solar system, fragments of comets and asteroids that broke apart long ago, streams of particles following orbital paths that sometimes, inevitably, intersect with Earth's path. Most of this material is small, grains of sand, pebbles. When they hit Earth's atmosphere, they burn up, creating the shooting stars we make wishes on. Harmless, beautiful even, but not everything is small, and not everything burns up. Every few million years, something large enough to survive the atmosphere strikes the surface. An asteroid a mile wide, a comet fragment travelling at tens of thousands of miles per hour. The impact releases energy equivalent to thousands or millions of nuclear weapons. The crater left behind can be dozens of miles across. The shockwave levels everything for hundreds of miles. Dust and debris are thrown into the stratosphere, blocking sunlight, cooling the planet, disrupting ecosystems. And if the impact is big enough, if it hits at just the wrong angle or in just the wrong place, it can trigger mass extinctions. We know this happens because we've found the craters. Chicxulub in Mexico, the impact that likely contributed to the extinction of the dinosaurs 66 million years ago. Vredefort in South Africa, more than 2 billion years old and over 180 miles wide. Dozens of others scattered across the planet, some obvious, some eroded almost beyond recognition. The geological record is clear. Earth gets hit regularly, and when it does, the effects can be catastrophic. But large impacts are rare on human timescales. The odds of a civilization-ending asteroid strike in any given century are low enough that we don't think about it much, low enough that it doesn't factor into most models of how societies rise and fall. Except there's another category of impact, smaller, more frequent, but still large enough to matter. And the evidence suggests these might follow patterns, cycles, periods when Earth passes through denser regions of the debris field and the likelihood of impact increases. Around 12,800 years ago, right at the beginning of the Younger Dryas, something happened. Across North America, Europe, and parts of Asia, a layer of sediment shows unusual markers, nanodiamonds, tiny carbon structures that form under extreme pressure and temperature, spherules, glassy beads created when rock melts and cools rapidly, high concentrations of platinum and iridium, elements rare on Earth's surface but common in asteroids and comets, and a layer of black carbon, evidence of widespread fires. This layer, found at dozens of sites across multiple continents, all dating to roughly the same time, suggests a massive impact event. Not a single large asteroid, but possibly a fragmented comet or a series of airbursts, explosions in the atmosphere from objects that didn't quite make it to the ground intact, but released their energy in the sky. The damage from an airburst can be just as severe as a direct impact. The Tunguska event in Siberia in 1908 flattened 800 square miles of forest, and that was from an object maybe 120 feet across. Now imagine multiple Tunguska-scale events happening simultaneously, or over a short period across an entire hemisphere. Forests would burn, the sky would darken, temperatures would drop, and anything living in the impact zones, human or otherwise, would face immediate devastation. This is called the Younger Dryas impact hypothesis, and it's controversial. Not all scientists agree the evidence is strong enough. Some argue the markers could have other explanations. But the debate itself is significant because it takes seriously the idea that cosmic events might play a role in sudden climate shifts, and by extension, in the collapse of early human societies. Because here's the thing, humans were just starting to thrive 12,800 years ago. The ice was retreating, the climate was warming, populations were growing. In North America, the Clovis culture, known for distinctive stone tools, was widespread. In the Middle East, people were experimenting with early forms of agriculture, and then, suddenly, everything changed. The climate reversed. Megafauna, animals that had survived previous climate shifts, began to go extinct, and the Clovis culture disappeared from the archaeological record. Could an impact event explain this? Could the sudden influx of dust and debris into the atmosphere, the fires, the destruction, have been enough to tip the climate back into Ice Age conditions and disrupt human societies that were just beginning to establish themselves? It's possible. And if it is possible, if cosmic impacts can act as triggers for rapid climate change, then they become part of the equation when we think about resets. But there's another layer. Some researchers have suggested that Earth's orbit brings it through certain regions of space more regularly than others, that there might be streams of debris, remnants of ancient comets, that Earth encounters on a periodic basis. And if that period happens to be around 12,000 years, or some multiple thereof, then the pattern we're seeing in the geological record might not be coincidence. It might be orbital mechanics, a rhythm dictated by where Earth is in its long journey around the galaxy, through regions of space that are more or less hazardous. This is speculative. We don't have enough data yet to confirm regular cycles of impact events, but we do know that the solar system passes through the galactic plane roughly every 30 million years, and that this might expose us to more comets from the Oort cloud. We do know that meteor showers, the predictable ones we see every year, occur because Earth passes through the debris trail left by specific comets. So the idea that there could be longer cycles, less predictable but still real, isn't absurd. And if those cycles exist, if there are periods when the likelihood of impact increases, then that's another variable in the reset equation. Another way the universe itself might impose structure on the history of life and civilization on this planet, not through intention, but through mechanics. the cold physics of orbits and trajectories and probability. Space doesn't target Earth. It doesn't care whether we survive or not, but it intersects with us. And when it does, the results can reshape everything. An impact doesn't have to destroy a civilization to reset it. It just has to disrupt it enough. Destroy crops, trigger famines, break trade routes, send populations fleeing, create conditions where complexity can't be maintained and systems start to collapse. And then, while everyone is still reeling, the climate shifts. The ice returns, or the rains fail, or the ocean currents change, and what might have been recoverable becomes catastrophic. One shock is survivable. 2 or 3 happening close together, cascading, amplifying, that's when things fall apart. This is how resets might work. Not through a single cause, but through convergence. Multiple systems reaching critical points at roughly the same time, triggered by cycles we only partly understand. The orbit of the planet, the tilt of its axis, the flow of its core, the debris field it travels through, each one following its own rhythm, and occasionally, inevitably, those rhythms align. When they do, the result is change, rapid, disorienting, unavoidable. The kind of change that erases what came before and forces whatever survives to start over. Not from scratch, but from fragments. From the pieces that happen to make it through. And if we're honest, we don't know when the next convergence will happen. We're watching the ice melt. We're tracking the magnetic field. We're mapping near-Earth asteroids. But we can't predict with certainty when all the factors will line up again. We can only observe the patterns in the past and recognize that the mechanisms are still active, still turning. The cosmos is patient, and it doesn't forget. There are stories written in the landscape that we've only recently learned to read. Valleys that were carved not by millions of years of erosion, but by catastrophic floods that lasted days. Gravel deposits hundreds of feet thick scattered across terrain where no river runs today. Enormous boulders, some the size of houses, perched on hillsides miles from their source, carried there by forces so violent they defy easy comprehension. These are the signatures of megafloods, and they happened more recently than we once thought. Not in the deep geological past, but during the transition from the last ice age to our current climate. In the window we're exploring, around 12,000 years ago. The most famous example is the Missoula floods in the Pacific Northwest of North America. At the end of the Ice Age, a massive ice dam held back a glacial lake called Lake Missoula, which contained more water than Lake Erie and Lake Ontario combined. When that dam failed, and it failed repeatedly as ice advanced and retreated, the water didn't drain slowly. It exploded across what is now Idaho, Washington, and Oregon, with the flow rate estimated at 10 times the combined flow of all rivers on Earth today. The flood moved at speeds up to 80 miles per hour. It carved canyons hundreds of feet deep in solid basalt in a matter of hours. It ripped boulders from the ground and carried them dozens of miles. It stripped away topsoil down to bedrock over an area of thousands of square miles. And then, when the water finally drained into the Pacific, it left behind a landscape so strange that for decades geologists couldn't agree on what had caused it. The idea of a flood that large was too extreme, too catastrophic. It didn't fit the prevailing view that geological change happened slowly, gradually over eons, but the evidence was undeniable, and once scientists accepted that megafloods could happen, they started finding evidence of them everywhere, not just in the Pacific Northwest, but across the Northern Hemisphere. In Siberia, where similar floods carved enormous valleys. In Central Asia, where glacial lakes drained and reshaped entire regions. In Europe, where the English Channel might have been widened by catastrophic flooding when an ice dam failed between what is now Britain and France. And then there's Lake Agassiz, which we've mentioned before but deserves closer attention. This was the largest glacial lake in North America, covering parts of what is now Manitoba, Ontario, Saskatchewan, North Dakota and Minnesota. At its peak, it held more water than all the current Great Lakes combined, and it was held in place by nothing more than ice. As the ice sheets melted, the lake grew, and as it grew, it found outlets. Sometimes it drained south into the Mississippi River system, sometimes east toward the Atlantic, sometimes north toward the Arctic Ocean, and each time it found a new outlet. Especially when an ice dam failed suddenly, it released massive volumes of fresh water into the ocean in a geologically instantaneous event. We've already talked about how fresh water can disrupt ocean circulation. The Atlantic meridional overturning circulation, the conveyor belt that moves warm water north and keeps the climate stable, depends on salinity. When huge amounts of fresh water pour into the North Atlantic, they dilute the salty water, prevent it from sinking, and shut down the circulation. And when the circulation stops, the climate in the Northern Hemisphere crashes. This is the leading explanation for the Younger Dryas, a catastrophic drainage of Lake Agassiz, possibly combined with other glacial lake outbursts, dumped so much fresh water into the North Atlantic that it disrupted the entire ocean current system. The conveyor stopped. Warm water stopped flowing north, and within years the climate reversed. But here's what's often overlooked. These floods weren't just climate triggers, they were catastrophic events in their own right. Anyone living downstream would have had no warning. One day there's a lake held back by ice. The next day, or perhaps within hours, that ice fails and a wall of water taller than a skyscraper comes roaring down valleys at highway speeds, obliterating everything in its path. If humans were living in those valleys, and we know humans were spreading across North America and Europe at the time, they would have been wiped out. Not just displaced, erased. Entire populations could have vanished in a single day. And because they were preliterate, because they left no written records, we have no direct accounts of what happened. Only the geological evidence of the floods themselves and the curious gaps in the archaeological record. There's also the question of sea level rise. When the ice sheets melted, sea levels rose by more than 400 feet. Not all at once, but over the course of a few thousand years. That sounds gradual until you realize what it means. Coastlines that had been stable for tens of thousands of years, where humans likely lived because coasts are rich in resources, disappeared underwater. River valleys became bays, islands vanished, entire lowland regions were drowned, and it didn't happen smoothly. There were periods of rapid rise, pulses when large sections of ice sheet collapsed and dumped their water into the ocean all at once. Meltwater pulse, May, around 4,600 years ago, saw sea levels rise by 50 to 80 feet in less than 500 years. That's a foot or more per decade. Fast enough that people would notice. Fast enough that coastal settlements would be abandoned. Fast enough that entire ways of life would have to change. Imagine you're living in a coastal village 14,000 years ago. Your people have lived here for generations. You know the tides, the fishing grounds, the safe places to gather shellfish. And then, over the course of your lifetime, the sea rises. Not gradually, but noticeably. Every few years, storms reach farther inland. The beaches you remember from childhood are underwater. The freshwater springs near the shore are now brackish. And finally, you have to move. You have to leave behind everything your ancestors built and find new land, higher ground, competing with other groups who are also being displaced. This happened. We know it happened because we've found submerged settlements, drowned forests, tools and artifacts on what is now the sea floor. The archaeological sites we have from this period are almost all inland because the coastal ones are gone, lost beneath hundreds of feet of ocean. And that means we're missing a huge part of the story. We're missing the people who lived along the coasts, who would have been most affected by the floods and the sea level rise, who might have developed complex societies earlier than we think but left no trace we can easily find. So when we talk about a reset 12,000 years ago, we're not just talking about climate, we're talking about landscapes being rewritten, about water in volumes that are hard to imagine, moving in ways that reshape continents, about entire regions becoming uninhabitable not slowly but suddenly, and about human populations, small and scattered as they were, facing disruptions that would have tested every strategy for survival they'd developed. Some groups survived, obviously, we're here, but how many didn't? How many societies, how many languages, how many ways of understanding the world were simply washed away? We'll never know. The water took them, the ocean covered them, and the ice, when it melted, erased the evidence of what had been there before. This is the nature of a reset. It's not just that things change, it's that the evidence of what came before is removed, deliberately, if such a word can apply to natural forces. The planet doesn't preserve everything equally. It preserves what happens to be in the right place, made of the right materials, buried at the right depth. Everything else dissolves, erodes, sinks beneath the waves, and so we're left with fragments, clues, a layer of flood deposits here, a submerged forest there, stories passed down through generations distorted and mythologized about great floods and lost lands, not proof of anything specific but suggestions, patterns, the outline of catastrophes we can only partially reconstruct, and the humbling realization that if this could be forgotten, if events this massive could fade from human memory and almost vanish from the geological record, then what else might we be missing? What other resets happened that we don't even have myths about anymore? The water remembers, in its way. It carved the evidence into the land, but it also covered it up, and we're only now learning how to read what's left. Let's slow down here for a moment. Let's take a breath and step back from the data, from the floods and the ice and the magnetic shifts, and just sit with what we've been exploring. Because sometimes the mind needs a rest. Sometimes wonder is best experienced in stillness, not in the accumulation of facts, but in the quiet space between them. We've been walking through layers of time, through catastrophes that reshaped the world, through cycles that pulse beneath the surface of things. And it's easy, when you're looking at evidence and timelines, to forget that these weren't abstract events. They happened to a living planet, to ecosystems, to animals, to people. 12,000 years ago, someone stood somewhere and looked at the sky, just like you might be looking at a ceiling or a window right now. They didn't know about ice ages or Milankovitch cycles or magnetic field reversals. They didn't have words for those things. But they knew when the weather changed. They knew when the animals disappeared. They knew when the water rose and the land they'd always known became something else. And they told stories about it. Not scientific papers, but stories, myths, ways of encoding what happened so that future generations would remember, even if they didn't fully understand. A great flood, a long winter, a time when the sky went dark. These weren't fantasies, they are memories, compressed and metaphorized, passed down until they became legend. There's something deeply human about that, about the need to remember even when you can't explain. about the urge to say to your children and your children's children, this happened and we survived it. Not because we were special or chosen, but because we adapted. Because we moved when we had to move. Because we found new ways when the old ways stopped working. Trauma lives in stories. So does resilience. And if every 12,000 years or so, the world goes through a period of instability, a reset of some kind, then humanity has lived through at least one already. The one we've been talking about. The transition from the Pleistocene to the Holocene, from Ice Age to the world we know, and we made it. Not unchanged, not without loss, but we made it. The people who came before us, the ones who watched the glaciers melt and the seas rise and the climate lurch from one extreme to another, they adapted, they learned, and they gave us the world we inherited, the one where civilization became possible. So maybe the question isn't just whether Earth resets every 12,000 years. Maybe it's also what we do when it happens, how we respond, whether we hold on too tightly to what was, or whether we find the flexibility to become something new. Because the Earth will do what it does. The cycles will turn, the ice will advance and retreat, the magnetic field will wander, meteors will fall, the crust will shift. These are not things we control. They're the conditions we live within, the boundaries of the game. But how we play, that's up to us. And maybe that's the real gift of exploring these deep patterns. Not to predict the end, not to live in fear, but to recognize that impermanence is woven into the fabric of everything. That the ground beneath us has always been less solid than it feels, and that knowing that, accepting it, can be strangely freeing. Because if nothing lasts forever, then this moment, right now, is more precious. This brief window of stability, this chance to look up at the stars and wonder, to build things even if they won't last, to love even if nothing is guaranteed, to be curious even if the answers are incomplete. The planet doesn't owe us permanence, but it gives us time. And what we do with that time matters, even if it doesn't last as long as we'd like. Even if someday, thousands of years from now, someone else will be doing what we're doing now. Sifting through layers, looking for clues, wondering if anyone came before them and what they might have known. Maybe they'll find traces of us. Maybe they won't. But we'll have been here. We'll have looked at the evidence, asked the questions, sat with the mystery. And that's not nothing. That's participation. That's being part of the long conversation between awareness and the universe it arises within. So rest here for a moment. Let the ideas settle. Let the weight of deep time and catastrophe and resilience just exist without needing to be solved. Because the best questions aren't the ones with easy answers. They're the ones that change how you see things, that make the ordinary world feel a little more mysterious, a little more alive. The cycles turn whether we notice them or not, but noticing them, thinking about them, feeling the texture of time and change and possibility, that's a kind of grace, a way of being awake to the strangeness and beauty of existing at all. And maybe that's enough for now. To be here in this moment, in this brief flicker between ice ages, wondering what comes next. Not with dread, but with a quiet, open curiosity. The kind that doesn't need certainty to feel meaningful. The kind that just wants to see. So let's keep going, gently. There's more to explore, more layers to uncover, but we can take our time. We can let the journey be as important as the destination. We can breathe and wonder and allow ourselves to be surprised by what we find. Because the universe is full of rhythms we're only beginning to hear. And learning to listen is its own kind of wisdom. When we look for evidence of early human civilization, We're limited by what survives, and what survives is not representative of what existed. It's a filtered record, biased towards certain materials, certain locations, certain kinds of preservation. Stone lasts, pottery lasts, if it is buried in the right conditions. Metal corrodes but sometimes leaves traces. Wood, fabric, rope, leather, all the organic materials that would have made up the majority of what people made and used, these decay, they vanish. So when we dig into sites from 10,000 or 15,000 years ago, we're seeing a fraction of what was there. We're seeing the durable remnants of cultures that might have been far more sophisticated than the stone tools and scattered bones suggest. We're seeing what the Earth chose to preserve, not what actually existed. And here's the difficult part. Most of the places where humans would have lived during the last ice age are now underwater or buried under sediment. Sea levels were 400 feet lower. The coastlines were completely different, and humans, like all intelligent animals, tend to live near water, rivers, lakes, coasts. These are where resources are abundant, where trade routes form, where communities can thrive. But those locations are gone now, drowned when the ice melted. If there were settlements along the ancient coasts, and there almost certainly were, they're beneath the ocean. And even if we find them, even if we send submersibles down to map the continental shelves, the sites will have been scoured by currents, buried in sediment, degraded by salt water. Most of what was there will be unrecognizable. This creates a gap in our understanding. The archaeological record from before 12,000 years ago is sparse, not because humans weren't doing anything interesting, but because we're looking in the wrong places, or because the right places no longer exist in a form we can easily access. Every now and then, something surprising emerges. A site that's older than expected or more complex than the prevailing theories would predict. And each time it forces a revision. Göbekli Tepe in Turkey is one example. It's a massive stone complex built around 11,500 years ago, before the development of agriculture, before pottery, before metalworking. Huge pillars carved with animals and symbols, arranged in circles, clearly requiring organization and labor and some kind of shared vision. It doesn't fit the narrative of simple hunter-gatherers barely scraping by. It suggests that even before the Neolithic Revolution, humans were capable of large-scale construction and symbolic thought. And if one site can overturn assumptions, how many more are waiting to be found, or have already been lost? The silence in the archaeological record before the 12,000-year mark might not reflect absence. It might reflect erasure, the planet resetting, as we've been discussing, and taking the evidence with it. This is why the idea of cyclical resets is so challenging for archaeology. If every 12,000 years or so there's a period of massive environmental upheaval, flooding, glaciation, sea level change, then anything built during the previous stable period gets destroyed or buried so deeply we'll never find it. The record resets along with the civilization. We can't prove earlier civilizations existed. But we also can't prove they didn't. The absence of evidence is not evidence of absence, especially when the conditions for preservation are so poor. All we can say is that if something was there, if humans or any other intelligent species developed complexity during a previous interglacial, the traces would be faint at best, and we might never recognize them for what they are. So we're left with questions, with gaps, with the uncomfortable acknowledgement that our understanding of the past is incomplete and will always be incomplete, that there are limits to what we can know, and that those limits are not just about our methods or our technology, but about the nature of time itself and the way the Earth recycles everything, including memory. The silence in the record is not neutral. It's shaped by the forces we've been discussing. By water and ice and time, and it reminds us that history is not a complete chronicle. It's a collection of fragments, carefully interpreted, but always provisional, always open to revision. And maybe that's okay. Maybe not knowing is part of the story. Maybe the gaps are as important as what we've found because they keep us humble. They keep us asking questions. They keep us looking. History is full of examples of civilizations that nearly disappeared without a trace. Not ancient pre-literate societies from before the Ice Age, but complex cultures with writing, architecture, trade networks, entire systems of knowledge that came perilously close to being forgotten completely. And these are societies that existed only a few thousand years ago, well within the stable period we're currently living in. If they can nearly vanish, what does that say about our ability to detect anything older? Take the Bronze Age collapse around 1200 BCE. Within a span of about 50 years, most of the major civilizations in the Eastern Mediterranean and Near East either collapsed or were severely diminished. The Hittite Empire fell. Mycenaean Greece fragmented. Egyptian power waned. Trade routes that had connected the region for centuries broke down. Cities were abandoned or destroyed. Writing systems disappeared. And the region entered what's often called a dark age, a period where complexity decreased and the archaeological record becomes sparse. We know this happened because enough survived to tell us. But imagine if it hadn't. Imagine if the collapse had been more complete, if the recovery had taken longer, if fewer texts had been preserved. We might have lost entire chapters of human achievement. Languages, technologies, stories, all gone, and future archaeologists would be left wondering what happened in the gap between earlier evidence and what came after. Or consider the Maya. At their peak, they built massive cities, developed sophisticated mathematics and astronomy, created detailed written records, and then, between the 8th and 9th centuries, many of their cities were abandoned. The population declined. The inscriptions stopped. For a long time, archaeologists assumed the civilization had simply collapsed and disappeared. It wasn't until relatively recently that we understood the Maya people didn't vanish. They moved, adapted, continued in different forms, but much of their knowledge was lost. Many of their books were destroyed by Spanish colonizers centuries later. And what we know about them now is a fraction of what they knew about themselves. The same pattern appears elsewhere. Angkor Wat in Cambodia, once the heart of the Khmer Empire, was abandoned and swallowed by jungle. For centuries it was forgotten except by local people. Great Zimbabwe, a massive stone complex in southern Africa, was built and then left empty, its history lost until archaeologists began to piece it together. The Indus Valley civilization, which flourished 4,000 years ago, had cities with advanced urban planning, but we still can't read their writing system. Their story is partially silent. These are civilizations that existed in the last few thousand years during the same stable climate period we're in now, and yet they nearly slipped through the cracks of history. If more time had passed, if conditions had been slightly less favorable for preservation, if there had been one more flood, one more conquest, one more fire, we might not know they existed at all. And these are just the ones we've found. How many others are there that we haven't? How many small kingdoms, trading networks, innovative societies existed briefly and then collapsed, leaving so little behind that we walk past their remains without recognizing them? The world is large, we've only excavated a tiny fraction of it, and every year new discoveries force us to revise what we thought we knew. Now extend that fragility backward, not 3,000 years, but 12,000. not during a stable climate period, but during a period of catastrophic environmental change. If civilizations from just a few thousand years ago can nearly disappear, what chance do earlier ones have? If the Bronze Age collapse can create gaps in the record that we struggle to interpret even with writing to guide us, what would a reset during the transition from the Ice Age look like? There would be no writing to reference, no monuments guaranteed to survive, no trade goods to trace, just scattered tools, bones, and the faint signatures of human activity. And if that activity happened in the wrong place, along a coast that's now underwater, or in a valley that was scoured by floods, then it's simply gone, erased. This is the unsettling truth. Complexity is fragile. It requires stability to build and maintain. And when stability fails, complexity collapses faster than it was built. Cities that took centuries to grow can be abandoned in decades. Knowledge that took generations to accumulate can be lost in a single generation if it's not written down or if the records are destroyed. We are not immune to this. Our civilization feels permanent because it's the only one we've known, but it depends on systems that are far more delicate than we usually acknowledge. Supply chains, power grids, communication networks, all of it requires constant maintenance and a functioning social order. Disrupt that order through climate change or resource collapse or conflict, and the systems fail. And when systems fail, complexity unravels. The question is not whether civilizations can collapse. We know they can. The question is how completely, how much survives, how much is remembered, and whether the next group that rises does so with any knowledge of what came before, or if they start from scratch, building on ruins they don't recognize as ruins. Every civilization thinks it will last. Every society assumes its knowledge is secure, but the record suggests otherwise. It suggests that forgetting is easier than remembering, that absence is more common than preservation, and that time, given enough of it, erases almost everything. So when we ask if Earth resets every 12,000 years, we're really asking if the conditions exist for that kind of erasure. And the answer, based on what we've seen, is yes. The mechanisms are there, the cycles are real, and the fragility of what we build is not a flaw, it's just a fact. We don't think of the sun as variable. It rises and sets, it provides light and warmth, it feels constant, reliable, like a clock that never needs winding. But the sun is not constant. It's a massive ball of plasma undergoing continuous nuclear reactions, with magnetic fields that twist and churn and occasionally release enormous amounts of energy in our direction. And those releases follow patterns, cycles. Some we understand, others we're still mapping. The most well-known is the 11-year solar cycle. Sunspot activity rises and falls in a rhythm that's been observed for centuries. During solar maximum, the sun's surface is covered with dark spots, regions where magnetic fields are so intense they suppress convection and cool the surface. During solar minimum, the spots disappear and the sun appears quiet. But quiet doesn't mean inactive. Even during minimum, the sun is still fusing hydrogen into helium, still releasing energy. It's just doing so more evenly. But there are longer cycles too. Cycles that operate on timescales of decades, centuries, even millennia. The Maunder minimum, from roughly 1645 to 1715, was a period when sunspots almost disappeared entirely for 70 years. During that time, Europe experienced what's called the Little Ice Age. Winters were harsher, growing seasons shortened, rivers that rarely froze became icebound. It wasn't a full ice age, but it was enough to cause crop failures, famines, and social instability. Was the sun responsible? Partly, perhaps. The reduced solar output during the Maunder minimum would have cooled the planet slightly, but there were other factors at play too. Volcanic eruptions, ocean current shifts. It's never just one thing, but the sun's variability was part of the equation, and that variability is not random. It follows patterns we're only beginning to understand. Tree rings and ice cores provide records of solar activity going back thousands of years. When cosmic rays strike the atmosphere, they produce isotopes like carbon-14 and beryllium-10. These isotopes get incorporated into tree rings and ice layers. When the sun is active, its magnetic field deflects more cosmic rays, so fewer isotopes are produced. When the sun is quiet, more cosmic rays get through and isotope levels rise. By measuring these isotopes, scientists can reconstruct solar activity over millennia, and what they've found is intriguing. There are periods, roughly every few thousand years, when solar activity drops significantly. Grand minima, like the Maunder minimum, but longer and deeper, and there's some evidence, tentative and debated, that these periods of low solar activity might align with other climate shifts. Not perfectly, not as a sole cause, but as a contributing factor. Another cycle layered on top of the others, the sun also produces solar flares and coronal mass ejections, explosions that send charged particles streaming toward Earth. Most of the time, our magnetic field deflects them. We see auroras as a result, beautiful curtains of light near the poles. But occasionally a particularly strong solar storm gets through. In 1859, the Carrington event, named after the astronomer who observed the solar flare that caused it, sent a massive pulse of charged particles toward Earth. When it arrived, it overwhelmed the planet's magnetic field. Telegraph systems across Europe and North America sparked and caught fire. Auroras were seen as far south as the Caribbean. If that happened today, with our dependence on electronics and satellites and power grids, the damage would be catastrophic, and it could happen again. The sun goes through active periods. We've been relatively lucky in recent decades, but that luck won't hold forever. Solar storms of the magnitude of the Carrington event or larger occur roughly once every few centuries. And if one hits during a period when our magnetic field is already weakened, as it appears to be now, the effects would be amplified. But there's another question. Do solar cycles operate on even longer timescales? Are there rhythms in the sun's behavior that span tens of thousands of years? Some researchers think so. They point to correlations between solar activity, climate events, and periods of rapid change in Earth's history. The data is noisy. The correlations are not perfect, but there are hints, suggestions that the sun, like the Earth, has longer rhythms that intersect with other cycles in ways we're only beginning to map. If that's true, if the sun's activity follows patterns that align with the 12,000-year cycle we've been exploring, then it's another variable in the reset equation. Not the trigger, but a contributor. A factor that, when combined with ice melt and magnetic field shifts and cosmic impacts, creates conditions where the climate becomes unstable and civilizations become vulnerable. The sun gives life, but it can also take it away, not through malice, but through variation, through the natural rhythms of a star that's still young, still active, still learning how to burn steadily. We orbit at just the right distance to benefit from its warmth. But that distance doesn't protect us from its storms, and those storms, when they come, remind us how dependent we are on forces we don't control. The sun will keep shining. It has billions of years left before it exhausts its fuel. But how it shines, how brightly, how stably, that changes. And those changes ripple through the solar system, affecting everything, including us, including the climate, including the chances that any complex system, biological or social, can maintain itself over long periods. We're learning to listen to the sun, to read its rhythms in ice and stone and light. And what we're learning is that it's not as steady as we thought, that it has moods, cycles, patterns that intersect with Earth's own rhythms in ways that matter, that shape history, that might, just might, help explain why the world resets when it does. The ground beneath us feels solid, unmoving, but it's not. It never has been. The Earth's crust floats on the mantle below, and that mantle, though solid on human timescales, flows over geological time. Plates drift, continents collide, mountains rise and erode, and occasionally suddenly the stored energy in the crust releases. Earthquakes, volcanic eruptions, the planet adjusting, finding balance, reminding us that solid is a relative term. We've talked about how the weight of ice affects the crust, how the melting of glaciers causes the land to rebound. But that rebound doesn't happen in isolation, it creates stress. When one part of the crust rises, adjacent areas must adjust. Faults that have been locked for millennia suddenly find new pressures applied. Old fractures reopen, new ones form. And the result is increased seismic activity. This isn't speculation. Studies of regions that were glaciated during the last ice age show clear evidence of increased earthquake activity during and after deglaciation. Scandinavia, for instance, is still experiencing earthquakes related to post-glacial rebound. The land is still rising, still adjusting, 12,000 years after the ice melted. And as it rises, stress builds in the surrounding crust. Faults slip, the ground shakes. But earthquakes aren't the only consequence. Volcanic activity also increases during deglaciation. When thick ice covers a volcanic region, it suppresses eruptions. The weight of the ice increases pressure on the magma chambers below, making it harder for magma to rise. But when the ice melts, that pressure is removed, suddenly. And magma that's been building up for thousands of years finds a pathway to the surface. Iceland is a perfect example. It sits on the mid-Atlantic ridge, where the North American and Eurasian plates are pulling apart. It's one of the most volcanically active regions on Earth, and studies show that volcanic activity in Iceland increased dramatically after the ice sheets melted. Not immediately, but within a few thousand years. The eruptions were larger, more frequent, more explosive. The planet was adjusting to the new configuration. The same pattern appears elsewhere. In the Pacific Northwest, Mount Mazama erupted catastrophically about 7,700 years ago, creating what is now Crater Lake. That eruption happened during the post-glacial adjustment period. In the Andes, several major volcanic eruptions occurred in the millennia following deglaciation. The timing is not random. The removal of ice changes the stress regime in the crust, and volcanoes respond. And volcanic eruptions have consequences beyond the immediate destruction. Large eruptions inject sulfur dioxide and ash into the stratosphere, where it can linger for years, reflecting sunlight and cooling the planet. The 1815 eruption of Mount Tambora in Indonesia caused the year without a summer in 1816. Crops failed across Europe and North America, famine followed, and that was from a single eruption. Imagine multiple large eruptions happening within a short period during an already unstable climate transition. The combination of increased seismic activity, volcanic eruptions, and rapid climate change creates a cascade. Each factor amplifies the others. An earthquake might trigger a landslide. A landslide might dam a river, creating a temporary lake. When that dam fails, flooding follows. A volcanic eruption might cool the climate, causing crop failures. Crop failures lead to migrations, conflicts, societal stress, and all of this happening simultaneously, or near enough, during the period when the ice is melting and the planet is fundamentally reconfiguring itself. This is what a tectonic reset looks like. Not a single event, but a period of heightened instability. A window of time when the crust is more active, more responsive, more likely to release the energy it's been storing, and that window, based on the evidence, appears to open during deglaciation, during the transition periods. During the times when ice is melting and continents are rebounding and the whole system is out of equilibrium. We're in a similar transition now, though the causes are different. The ice is melting. Greenland and Antarctica are losing mass. The crust beneath them will eventually rebound. And when it does, when those continents rise and the stress redistributes, the surrounding regions will feel the effects. More earthquakes in some areas, more volcanic activity in others. The timeline is uncertain. It could take centuries. But the process has begun. The Earth is patient. It doesn't rush, but it also doesn't forget. Energy stored in the crust will eventually be released. Stress will eventually find resolution. And when it does, the surface changes, sometimes dramatically. Sometimes in ways that make it hard for anything built on that surface to survive intact. Civilizations don't plan for tectonic timescales. We build on what feels stable. We assume the ground will stay where it is. But the ground has its own agenda, its own rhythms, and occasionally, inevitably, those rhythms assert themselves. There's a story written in our DNA, a story not of triumph, but of survival, of populations pushed to the edge, of numbers so small that every human alive today, all 8 billion of us, can trace our ancestry back to a few thousand individuals who lived through a crisis we can barely imagine. The most famous bottleneck occurred around 70,000 years ago. Genetic evidence suggests that the human population crashed to somewhere between 3,000 and 10,000 individuals. We came terrifyingly close to extinction. The leading theory is that the Toba supervolcano eruption in Indonesia triggered a volcanic winter, plunging global temperatures and making survival nearly impossible for most populations. Only a few groups in Africa, possibly in refugia where conditions remain tolerable, made it through. But that's not the only bottleneck in human history. The genetic record shows other periods where diversity decreased, where populations contracted. Not as severely as Toba, but enough to leave a mark. And some of these appear to cluster around climate transitions, around periods when the world was changing rapidly and resources became scarce. The end of the last ice age would have been one of those periods. As the climate shifted, as ice melted and seas rose and ecosystems reorganized, human populations would have faced enormous challenges. Some groups would have thrived in the new conditions, others would have struggled, and in regions where the changes were most severe, where flooding or drought or the collapse of prey populations made survival difficult, populations would have crashed. We don't have precise genetic dating for smaller bottlenecks. The signal gets noisy. But there are hints, studies of mitochondrial DNA, which is passed down through the maternal line, and Y chromosome DNA, passed through the paternal line, both show patterns consistent with population contractions around the time of the Younger Dryas. Not a near-extinction event, but a significant reduction. Enough to reduce genetic diversity in ways we can still detect today. And it's not just humans. Other species show similar patterns. Genetic studies of animals that lived through the Ice Age transitions reveal bottlenecks. Population crashes followed by slow recoveries. Megafauna, the large animals like mammoths and giant sloths, didn't make it through at all. They went extinct. But smaller, more adaptable species survived, often with reduced numbers and genetic diversity. This tells us something important. The transitions, the resets, are selective. They don't kill everything, but they cull, they reduce, they favor certain traits, adaptability, mobility, the ability to survive on limited resources and punish others. Specialization, dependence on specific ecosystems, slow reproductive rates. Civilizations, in a sense, are like specialized species. They depend on specific conditions, stable climate, predictable resources, functioning trade networks. When those conditions disappear, when the environment changes faster than the civilization can adapt, collapse follows, and the populations that survive are not necessarily the ones that were largest or most advanced. They're the ones that were flexible, the ones that could move, improvise, let go of complexity when complexity became a liability. The genetic bottlenecks remind us that we've been here before, not as a civilization, but as a species. We've faced resets, we've survived by adapting, by becoming smaller and more mobile, by prioritizing survival over everything else. And then, when conditions stabilized, we rebuilt. We expanded, we became complex again. But each time we go through a bottleneck, we lose something. Genetic diversity decreases, cultural knowledge is lost, languages disappear. The groups that don't make it through take their innovations with them, and what emerges on the other side is not the same as what went in. It's a subset, a remnant, a population that carries forward only a fraction of the diversity that existed before. This is why the 12,000-year cycle matters. If it's real, if the planet does reset with some regularity, then we're living in a window between events, a period of relative stability that allowed us to grow, to diversify, to build complexity, but that window won't last forever. And when it closes, when the next transition comes, we'll face the same pressures our ancestors faced, the same choices: adapt or collapse, simplify or disappear. The difference is that we know more now. We have records, we have science, we can see the patterns, but knowing doesn't guarantee survival. It only gives us options, and whether we use those options wisely, whether we prepare for instability instead of assuming stability will last forever, that remains to be seen. The genetic record is a warning, a reminder that survival is not guaranteed, that populations, even successful ones, can be reduced to fragments, and that what we are now, the diversity and complexity we've achieved, is contingent. It depends on conditions that have existed for a relatively short time and might not exist indefinitely. We carry the evidence of past resets in our cells, in the patterns of our DNA, in the diversity we lost and the resilience we gained. And maybe that's the most important lesson, that we are the descendants of survivors, people who made it through when others didn't, and that whatever comes next, whatever the planet has in store, we have at least some capacity to endure. But endurance comes at a cost, and the question is whether we're willing to pay it. The ocean doesn't forget. It records everything, every volcanic eruption, every meteor impact, every shift in climate. All of it settles into the sediment at the bottom of the sea, layer by layer, year by year, building a chronicle that stretches back millions of years. And unlike the land, which is constantly being reshaped by erosion and tectonics, the deep ocean floor is relatively undisturbed. It's one of the most complete archives we have of Earth's history. Scientists drill cores from the ocean floor, pulling up cylinders of sediment that can be dozens of meters long. Each layer represents a slice of time. The composition tells a story. The colour, the texture, the types of microfossils preserved, the chemical isotopes, all of it provides clues about what the world was like when that layer was deposited. And what they've found when they look at the layers from around 12,000 years ago is change. Rapid, dramatic change. Layers of sediment that indicate sudden shifts in ocean temperature. Changes in the types of plankton preserved, suggesting that surface water chemistry changed quickly. Anomalies in isotope ratios that point to massive influxes of fresh water, exactly what we'd expect from catastrophic melting of ice sheets. The ocean also records dust. When the climate cools and vegetation dies back, winds pick up more dust from exposed land and carry it out to sea. That dust settles into the sediment. During ice ages, dust layers are thick. During warm periods, they're thin. And at the transitions, at the boundaries between ice age and interglacial, the dust signatures change abruptly. The ocean knows when the wind patterns shifted, when deserts expanded or contracted, when the world became drier or wetter. There are also ash layers. When a volcano erupts with enough force to send material into the stratosphere, that ash can travel thousands of miles before settling, and when it lands in the ocean, it creates a distinct layer, often rich in glass shards and specific minerals that can be chemically fingerprinted back to the source volcano. These ash layers act as time markers. They tell us exactly when certain eruptions occurred and how widespread their effects were. Around the time of the Younger Dryas, there are multiple ash layers in ocean sediment cores from different parts of the world. This suggests increased volcanic activity, which aligns with what we discussed earlier about post-glacial eruptions, but it also suggests that the atmosphere was being filled with aerosols, particles that would have reflected sunlight and cooled the planet further. Another feedback loop, another way the systems interlock and amplify each other. The ocean also preserves evidence of impacts. When a large meteor or comet strikes the Earth, it vaporizes rock and sends debris into the atmosphere. Some of that debris eventually settles into the ocean, and if the impact is large enough, it can create a tsunami that deposits unusual sediment layers far from shore. Geologists have found such layers, mixed sand and marine material deposited suddenly on top of older sediments, dating to periods of known or suspected impacts. One of the most intriguing findings is the presence of spherules, tiny glassy beads formed when molten rock is ejected into the air and cools rapidly. These are found in sediment layers dating to the beginning of the Younger Dryas. They're consistent with an impact event or a series of airbursts. The distribution is wide, spanning multiple continents and ocean basins, which suggests the event, whatever it was, affected a large area. The ocean remembers what the land forgets. While coastlines were drowned and river valleys were scoured and forests burned, the ocean quietly collected the evidence. It recorded the temperature changes, the chemical shifts, the ash and dust and debris. And now, thousands of years later, we're learning to read that record, to pull it up from the depths and translate it into a narrative of what happened. And what it tells us is that the transitions are messy. They're not smooth, they're full of spikes and anomalies and sudden shifts. The climate doesn't glide from one state to another. It lurches, it stutters, it overshoots and corrects. And during those transitions, the ocean itself changes. Currents shift, salinity gradients alter, upwelling zones move, and all of that affects the ecosystems that depend on the ocean, which is most of them. Coastal human populations, which would have been significant during the Ice Age, would have faced collapsing fisheries, changing shorelines, and storms intensified by shifting ocean currents. The ocean wasn't just a passive backdrop. It was an active participant in the reset, responding to the melting ice and the changing climate, and in turn affecting everything that's depended on it. So when we ask what a reset looks like, part of the answer is written in ocean sediment, in the layers that show rapid change, in the ashen dust and isotopes that tell us the planet was in flux, in the evidence that systems we think of as stable, like ocean circulation and marine ecosystems, can shift dramatically when the conditions change. The ocean holds the memory, patient and deep and mostly unseen. But it's there, waiting for us to ask the right questions and look in the right places. And when we do, it tells us that the resets are real, that they've happened before, and that the planet, when it shifts from one equilibrium to another, leaves a record, not in monuments or texts, but in mud. There's a curious thing about human mythology. Cultures separated by oceans, by thousands of miles, with no contact, no shared language, no trade routes between them, tell remarkably similar stories. Stories of great floods, of worlds ending in fire or ice, of a time before this time, when everything was different, when giants walked the earth, or gods lived among humans, or the sky fell. We tend to dismiss these as fantasy, as the product of imagination, metaphor, the human need to explain natural phenomena through narrative, and surely much of mythology is exactly that. But what if some of it isn't? What if buried within the metaphors and the supernatural elements there are memories, distorted, mythologized, passed down through so many generations that the facts have become legend, but memories nonetheless? The flood myths are the most striking. Nearly every culture has one. The biblical story of Noah is perhaps the most famous in the West, but it's far from unique. The Epic of Gilgamesh, from ancient Mesopotamia, tells of Utnapishtim, who survived a great flood sent by the gods. Greek mythology speaks of Deucalion and Pyrrha, the sole survivors of a deluge sent by Zeus. Hindu texts describe Manu, who was warned of a coming flood and built a boat. Chinese legends tell of Gunyu taming the great floods. Indigenous peoples of the Americas, from the Pacific Northwest to the Amazon, have flood stories. Australian Aboriginal traditions speak of rising waters that drowned the land. These stories span continents. They produced writing in many cases, meaning they were preserved orally for thousands of years before anyone wrote them down. And while the details differ, the core is consistent. Water came. It rose suddenly and catastrophically. Most people died. A few survived by building boats or fleeing to high ground. And afterward, the world was different, renewed, reset. Could these be cultural memories of the end of the last ice age, of the sea level rise that drowned coastlines, of the catastrophic floods from bursting glacial lakes, of the younger Dryas and the rapid climate shifts that came with it? It's impossible to prove. Oral traditions are fluid. They change with each telling. But the fact that flood myths are so widespread, and that they often contain specific details like the water rising for a certain number of days or reaching a certain height, suggests they might be rooted in actual events. There are other alignments too. The Hopi people of the American Southwest speak of multiple worlds, each ending in catastrophe and giving way to the next. According to their tradition, we're living in the fourth world. The previous three were destroyed by fire, ice, and flood. The details are mythological, but the structure, cycles of destruction and renewal, echoes the geological pattern we've been exploring. Hindu cosmology describes yugas, vast cycles of time during which the world goes through phases of creation, maintenance, and destruction. The cycle repeats. Each yuga lasts thousands of years, and at the end of each cycle, the world is cleansed and begins again. Similar cyclical views appear in Norse mythology with Ragnarök, the end of the world followed by rebirth, and in Mesoamerican traditions, where the Aztecs believed we are living in the fifth sun, the previous four having been destroyed. These aren't scientific documents, they don't provide dates or mechanisms, but they do provide a pattern, a way of understanding the world that accepts impermanence, that expects cycles, that prepares mentally and culturally for the possibility that everything can change. And maybe that's significant. Maybe cultures that experienced resets, that lived through catastrophic climate shifts or floods or periods of instability, developed myths to encode that experience, to pass down the knowledge, even in symbolic form, that stability is temporary, that the world has ended before and can end again. There's also the possibility that some myths preserve more specific information. Stories of fire from the sky could be memories of meteor impacts or airbursts. Tales of the earth shaking and mountains falling could reflect major earthquakes or volcanic eruptions. Legends of long winters or times when the sun didn't shine properly could reference volcanic winters or periods of reduced solar activity. Stripped of the divine explanations and supernatural actors, some of these stories might be describing real events. We'll never know for certain. The distance between the events and the stories is too great. Too much has been lost or transformed. But the alignment is striking, and it raises the question of whether mythology should be taken more seriously as a historical source, not in its literal details, but in its broad patterns, in what it tells us about how people understood their world and the changes they witnessed. Because if the 12,000-year cycle is real, if resets happen with some regularity, then the people who lived through the last one would have noticed. They would have told their children, and those children would have told theirs, and eventually the story would become myth. The facts would blur. The causes would be attributed to gods or magic, but the core memory, that the world changed, that stability ended, that survival required adaptation, that would remain. And maybe that's the real gift of mythology. Not that it tells us exactly what happened, but that it reminds us something did, that the past was not static, that our ancestors lived through times of upheaval and found ways to endure, and that their stories, however transformed, are still here, still speaking, still warning us that the world we know is not the only world there's ever been. Is the reset random, or is it built into the system? That's the question that lingers once you've looked at all the evidence, all the cycles, all the patterns. Because if it's random, if it's just bad luck when ice melts and climates shift and civilizations collapse, then there's no deeper meaning to it. It's just entropy, chaos, the universe doing what it does. But if it's built in, if the reset is part of how the planet regulates itself, maintains balance, corrects imbalances, then it means something different. It means the Earth isn't just a passive stage where life happens. It means the planet itself is part of the system, an active participant. This idea isn't new. The Gaia hypothesis, proposed by scientist James Lovelock in the 1970s, suggests that Earth functions as a self-regulating system, that life and the physical environment interact in ways that maintain conditions suitable for life. The planet, in this view, isn't just rock and water and atmosphere. It's an integrated whole where biological and geological processes are linked, where feedback loops keep things from going too far in any direction. Critics have argued that Gaia implies intention, consciousness, purpose, things that can't be scientifically tested. And Lovelock himself clarified that he wasn't suggesting the planet thinks or plans, just that it behaves through purely physical and chemical processes as if it's self-regulating, like a thermostat. When things get too hot, mechanisms kick in to cool them down. When they get too cold, warming processes dominate. Ice ages might be one of those mechanisms. When CO2 levels drop, the planet cools, ice forms. Ice reflects sunlight, cooling the planet further. Eventually, volcanic activity or other processes release enough CO2 to warm things up again. The ice melts, sea levels rise, and the cycle continues. It's not intentional, it's just feedback. But from the outside, it looks like the planet is resetting itself, returning to baseline, correcting excesses, and maybe civilizations are one of those excesses. Not because they're bad or wrong, but because they represent a concentration of energy and resources. They alter ecosystems, they change atmospheric composition, they shift the balance. And when civilizations grow large enough, complex enough, they become vulnerable, not to punishment, but to the same forces that regulate everything else. When systems get too far from equilibrium, they correct, and the correction can be abrupt. This doesn't require any mysticism, it's just thermodynamics. Systems that consume energy faster than they can replace it eventually collapse. Civilizations that depend on specific climate conditions become unstable when these conditions change. It's not personal, it's not fate, it's just how complex systems behave when pushed beyond their limits. But there's another possibility, that the resets aren't corrective at all, that they're just the natural rhythm of a dynamic planet. Earth isn't trying to achieve balance, it's just moving through states. Ice Age, interglacial, Ice Age, interglacial. Each state has its own characteristics, its own climate, its own opportunities and constraints. And life, including intelligent life, adapts or doesn't, thrives or struggles, depending on which state the planet happens to be in. In this view, there's no intent, no purpose. The cycles exist because of orbital mechanics and solar variability and the physics of ice and ocean currents. They would happen whether life existed or not, and the fact that they disrupt civilizations is incidental. A side effect. The planet isn't resetting us, it's just being itself, and we happen to be living on it during one of its transitions. Both views have merit, both are consistent with the evidence, and maybe the truth is somewhere between them. Maybe the planet is self-regulating in some ways but indifferent in others. Maybe it maintains conditions that allow life to persist, but doesn't care about any particular form of life or any specific civilization. Maybe the resets are both mechanical and consequential, physics that happens to have meaning for anything trying to build something lasting. What matters, perhaps, is not whether the planet intends anything, but how we respond. If we see the resets as inevitable, as built into the system, does that change how we live? Do we build differently, plan differently, value stability less and adaptability more? Or do we do what we've always done, which is assume the current conditions will last and hope we're not the ones who have to deal with the change? Because here's the uncomfortable truth. Whether the reset is intentional or not, whether it's correction or just rhythm, the outcome is the same. Civilizations that can't adapt don't survive. Knowledge that isn't preserved is lost. Complexity that can't withstand disruption collapses. And the planet continues, indifferent or nurturing, depending on how you want to see it, moving through its cycles, creating new opportunities for whatever comes next. Maybe the question of intent is the wrong question. Maybe what matters is recognizing that we're part of a system much larger than us, that the forces shaping our world don't pause for our convenience, that the ground we stand on is temporary, the climate we depend on is conditional, and the stability we've enjoyed is not guaranteed. And maybe, if we accept that, If we stop expecting permanence and start preparing for change, we give ourselves a better chance, not to prevent the reset, but to survive it, to be the ones who carry something forward, not unchanged but continuous, still asking questions, still wondering, still here. Let's bring this forward, out of the past and into the present, because if resets happen, if the cycle continues, then it's not just a historical curiosity, it's a question about our future. What would a reset look like now? Not 12,000 years ago when humans lived in small groups and had few possessions, but today, when we've built a global civilization that depends on systems so interconnected that a disruption in one place cascades everywhere. It probably wouldn't look like a Hollywood disaster movie. No sudden apocalypse. No single day when everything ends. Instead, it would be gradual, a series of disruptions that compound, that overwhelm our ability to respond, that push systems past their breaking points one after another until complexity becomes unsustainable and societies begin to simplify, not by choice but by necessity. Start with climate. We're already seeing it destabilize. Temperatures rising, weather patterns shifting, droughts lasting longer, storms growing more intense, ice melting faster than models predicted. These aren't future problems, they're happening now, and they're creating stress, crop failures in some regions, water shortages in others, wildfires, floods, coastlines eroding, small disruptions mostly, manageable for now, but they're increasing in frequency and severity. Now add infrastructure, power grids designed for different climate conditions, roads and bridges built assuming certain temperature ranges, water systems that depend on predictable rainfall, all of it aging, all of it requiring maintenance, and all of it starting to fail more often as the conditions it was designed for no longer apply. A heat wave knocks out power, a storm floods a subway system, a drought empties a reservoir. Each event is recoverable. But when they start happening simultaneously, when the repair crews are overwhelmed and the resources are stretched, recovery slows, and systems that depend on those systems start to falter too. Supply chains would be among the first casualties. We've built a world where goods travel thousands of miles from production to consumption. Food, medicine, electronics, fuel, all of it moving constantly through networks that assume stability. Assume roads will be passable, ports will be open, fuel will be available. But if climate disruptions make transportation unreliable, if storms close ports or droughts dry up rivers used for shipping or fuel becomes scarce, the whole system seizes. Shelves empty, prices spike, and people start hoarding, which makes the shortages worse. Agriculture would struggle. Modern farming is optimized for specific conditions, specific rainfall patterns, specific temperature ranges, specific growing seasons. When those conditions shift, yields drop. Pests that were kept in check by cold winters survive and spread. Droughts kill crops, floods wash away topsoil, and farmers, who operate on thin margins, can't absorb multiple bad years in a row. Some give up, some go bankrupt, and the food supply, which we take for granted, becomes unreliable. Governments would face impossible choices: allocate resources to disaster response or maintain services, support failing industries or let them collapse, open borders to climate refugees or close them. Each decision creates new problems. Tensions rise, trust erodes, and in some places the social fabric starts to tear. Protests, riots, conflicts over resources, not everywhere, not all at once, but in pockets. In regions where the stress is highest and the capacity to respond is weakest. And then there's the cascade. Power outages that shut down water treatment plants, water shortages that affect industrial cooling systems, industrial shutdowns that disrupt supply chains, supply chain disruptions that lead to shortages that lead to panic that leads to instability. Each system depends on others, and when one fails, it pulls others down with it. This is what makes modern civilization fragile. Not any single point of failure, but the interconnectedness, the lack of redundancy, the assumption that everything will keep working. A reset wouldn't require an asteroid impact or a supervolcano. It would just require enough disruption, sustained long enough, that we can't maintain the systems we've built. And once those systems start to fail, once complexity becomes a liability rather than an advantage, societies simplify, cities depopulate, trade contracts. Technology that requires specialized manufacturing and global supply chains becomes unusable, and people adapt. They become more local, more self-sufficient, more focused on immediate survival than long-term planning. This isn't inevitable. We have knowledge our ancestors didn't. We have technology. We have the ability to see the patterns and respond. But response requires will. It requires accepting that the stability we've known isn't permanent, that the systems we depend on need reinforcement, redundancy, adaptation, and it requires doing that before the crisis, not during it, which is hard. Because humans are very good at ignoring slow-moving threats until they're immediate. So what would a modern reset look like? It would look like complexity collapsing under its own weight. Like systems designed for one world trying to function in another. Like societies fracturing under stress they weren't designed to handle. Not extinction. Not the end of humanity, but the end of this particular configuration. This particular way of organizing ourselves. And what comes after would be different. Smaller. Simpler. Built on what survives. On the knowledge we manage to preserve and the adaptations we make under pressure. And maybe that's not the worst outcome. Maybe resets, painful as they are, create space for something new, for different ways of living, for lessons learned, for a civilization that's less fragile because it remembers what fragility costs. Or maybe we find a way through. Maybe we adapt in time. Maybe the reset this time doesn't have to be complete. Maybe we get to keep some of what we've built. Not all of it, but enough. The future isn't written, but the patterns are there, and they're worth paying attention to. So here we are, after all the evidence, all the cycles, all the patterns and possibilities. Where does that leave us? We don't have proof that Earth resets every 12,000 years. We have suggestions, correlations, rhythms that might be meaningful or might be coincidence. We have geological data that shows the planet goes through periods of dramatic change. We have myths that hint at memories of catastrophe. We have systems, ice and ocean and magnetic fields that operate on timescales that occasionally align, but we don't have certainty. And maybe that's the point. Maybe the value isn't in knowing for sure, but in living with the question, in accepting that the world is more dynamic, more unpredictable, more alive than we usually acknowledge, in recognizing that the stability we've enjoyed is recent and possibly temporary, and in adjusting how we think, how we plan, how we build based on that recognition. Science doesn't require belief. It requires observation, hypothesis, testing. And when the data is incomplete, when the timescales are too long to observe directly, it requires humility, the willingness to say we don't know and might never know, but also the willingness to take the patterns seriously, to consider what they might mean, to prepare for possibilities even without certainty, because uncertainty is not the same as ignorance. Uncertainty is honest. It's what you have when you're dealing with complex systems over vast timescales. When you're trying to predict the behavior of a planet that's been surprising us for as long as we've been paying attention. And the appropriate response to uncertainty is not paralysis or denial. It's vigilance, awareness, flexibility. We can't stop the cycles. We can't prevent ice from melting, or magnetic fields from shifting, or the sun from varying. These forces are too large. But we can notice them, we can track them, and we can build societies that are less brittle, less dependent on the assumption that tomorrow will look like today, more capable of absorbing shocks without collapsing entirely. That means redundancy, multiple ways of doing essential things instead of single optimized pathways. It means local resilience, communities that can function even when global systems fail. It means preserving knowledge in ways that survive disruption, not just in digital form, which requires power and infrastructure, but in books, in skills passed down, in cultural memory. It also means changing how we relate to the planet, not as a resource to be extracted or a stage to perform on, but as a system we're part of, one that has its own rhythms and limits, one that will continue with or without us, and that works better for everyone when we pay attention to its signals instead of ignoring them. None of this is radical, it's practical. And it's not about fear, it's about respect for the forces that shape the world we live in, for the ancestors who survived previous disruptions, for the future generations who will face their own challenges, whatever form those take. Living with uncertainty also means letting go of the need for control. We can't control the planet. We can't dictate when cycles turn or how systems behave. What we can control is how we respond, whether we adapt or resist, whether we prepare or hope for the best, whether we learn from the patterns of the past or assume they don't apply to us. And there's a kind of freedom in that, in accepting that we're not in charge of everything, that some forces are larger than us, that our role is not to dominate or prevent but to participate, to be part of the system in a way that's sustainable, that allows us to persist through changes instead of being erased by them. The 12,000-year cycle, if it's real, is not a countdown, it's not a deadline, it's a rhythm, and rhythms don't have to be feared. They can be danced with, anticipated, respected. The planet has been through this before, life has been through this before, and it continues. Changed, yes, reshaped, but continuous. We have advantages our ancestors didn't. We have global communication, we have data, we have the ability to see patterns across vast distances and timescales. We have technology that, if used wisely, could help us weather disruptions that would have been catastrophic in earlier eras. But we also have vulnerabilities they didn't. Our complexity, our interdependence, our assumption of permanence. The question's whether we can hold both. The advantages and the vulnerabilities, the knowledge and the humility, the capacity to build and the wisdom to know when to simplify, whether we can live in a way that's sustainable not just for decades but for millennia. That doesn't assume the current conditions will last forever. That prepares for the possibility that they won't. This isn't pessimism, it's realism. And it's also, strangely, optimistic. Because if civilizations have risen and fallen before, if humanity has survived resets and rebuilds, then we're more resilient than we think. We're adaptable, we're creative, we find ways through. Not perfectly, not without loss, but we continue. And maybe that's enough. Not to last forever, which nothing does, but to persist. To carry something forward. To be part of the long story of consciousness trying to understand itself and the universe it finds itself in. to ask questions even when the answers are uncertain, to build even when we know nothing is permanent, to wonder even in the face of forces much larger than us. The cycles will turn. The planet will do what it does, and we'll be here, for now, watching and learning and adapting, living not in certainty but in the space between what we know and what we wonder, and finding meaning not in permanence but in presence, in being here, in paying attention, in doing what we can with the time we have. Let's pull back now, all the way back, not just to 12,000 years ago, but across the full span of Earth's history. 4.5 billion years, billions with a B. A timescale so vast that human civilization, all of it, from the first settlements to the present moment, is less than a pixel on the timeline, a flicker, a breath. And yet, within that flicker, so much has happened. We've gone from small bands of hunter-gatherers to a globally connected species capable of splitting atoms and leaving the planet. We've created art and music and mathematics. We've asked questions about where we came from and where we're going. We've looked at the stars and wondered if anyone else is out there doing the same. That's remarkable. Not because it makes us special in some cosmic sense, but because it represents possibility. The possibility that matter can organize itself into patterns complex enough to be aware, to think, to feel, to wonder. And if it's happened once, on this planet, during this particular window of stability, then maybe it's happened before, or will happen again. Maybe intelligence isn't a one-time occurrence, but something that emerges periodically when conditions allow. If Earth does reset every 12,000 years or so, if civilizations rise and fall in the spaces between disruptions, then we're not unique. We're part of a cycle. One attempt among many, and that's both humbling and comforting. Humbling because it means we're not the pinnacle of anything, we're just the current iteration, but comforting because it means we're not alone in our fragility. That impermanence is universal, that everything that has ever existed has faced the same truth, that nothing lasts, and yet existence continues. There's beauty in that continuity, in the way life keeps finding pathways, keeps adapting, keeps trying, even when conditions are hostile, even when resets erase what came before. The planet continues, the cycles turn, and eventually, when stability returns, complexity emerges again. Different forms, perhaps, different strategies, but the drive toward organization, toward awareness, that seems to persist. We think of ourselves as the result of linear progress, as if history has been building toward this moment, toward us. But what if it hasn't? What if history is circular or spiral, rising and falling, building and collapsing, but each time carrying forward something? Not artifacts or buildings, those don't survive, but patterns, possibilities, the memory encoded in genes and myths, and the very structure of how consciousness works. Maybe intelligence is the universe's way of trying to understand itself, and maybe it keeps trying because the first attempt, or the 10th, or the 100th, doesn't last long enough to complete the task. So it starts over, not from zero, because the conditions that produce intelligence are still there, but from fragments, from whatever survived, and each time it explores a different path, asks different questions, sees the world through different eyes. If that's true, then our purpose isn't to last forever, it's to participate, to add our perspective to the long conversation, to notice what we can notice, wonder what we can wonder, and pass forward whatever fragments might be useful to whoever comes next. Whether that's our descendants or something entirely new, the long view doesn't make individual lives less meaningful, it makes them more precious. Because if time is vast and resets are inevitable, then this moment, the one we're living in right now, is rare. It's a window, a chance, and what we do with it matters, not because it will last forever, but because it's happening now, because we're here to experience it, to shape it, to be part of it. And maybe that's the real lesson of the 12,000-year cycle. Not that we should fear the future or cling to the past, but that we should be present, fully here, aware of the forces that shape our world, grateful for the stability that allows us to exist at all, and humble about our place in the larger pattern, because the planet doesn't exist for us. It existed long before we did, and will exist long after. But while we're here, while we have this brief window of awareness, we get to participate. We get to look at the stars and wonder. We get to dig into the past and ask what came before. We get to build things, even if they're temporary. We get to love and create and question and be amazed. And when the cycle turns, when the next reset comes, whenever that is, something of what we've done will remain. Not in physical form, probably, but in the fact that we were here, that we tried, that we added our note to the song that the universe has been singing since the beginning. The cycles turn, ice ages come and go, magnetic fields shift, continents drift, and through it all, awareness flickers into existence, burns briefly and fades, but it keeps coming back. Different forms, different contexts, but the same fundamental miracle. Matter organizing itself into patterns complex enough to ask why. And maybe that's enough. Maybe that's everything. Not permanence, but presence. Not certainty, but wonder. Not control, but participation. Being part of something larger, something that continues, something that, despite all the resets and collapses and endings, keeps reaching toward understanding. We're here now, in this window, between whatever came before and whatever comes next. And that's not nothing, that's the gift. The chance to be conscious, to notice, to care, to ask questions even when the answers are uncertain, to build even when we know nothing is permanent, to wonder even when the universe is too large to fully comprehend. The long view doesn't diminish us, it places us, not at the center, but within, part of a pattern that's been unfolding for billions of years and will continue for billions more, a pattern of emergence and dissolution, of complexity arising from simplicity and returning to it, of consciousness waking up, looking around and asking what it all means. And maybe the answer is that it means what we make it mean, in the time we have, with the awareness we've been given, in this brief, precious, impermanent moment. So we've travelled far tonight, through ice and stone, through cycles that span millennia, through floods that reshaped continents and magnetic fields that wander, through myths that carry memories and oceans that never forget, through the possibility that Earth resets, not with malice but with rhythm, and that we're living in one of those brief windows between changes. And here we are, at the end of the journey, not with answers, but with perspective, with the recognition that the world is stranger and more dynamic than our daily lives suggest. That stability is recent and possibly temporary, that the ground beneath us is part of a system much larger than we usually acknowledge, and that our place in that system is both smaller and more meaningful than we might have thought. You've been listening all this time, wherever you are, whatever time it is where you are. Maybe you're in bed, maybe in a chair, maybe somewhere in between waking and sleeping, and that's perfect, because this question, this wondering about cycles and resets, and whether we're the first or the millionth attempt at consciousness on this planet, it's not something that needs to be solved tonight. It's something to carry gently, to let settle, to return to when you're ready. The 12,000-year pattern might be real. It might be coincidence. It might be something in between, a loose rhythm that becomes more apparent when we look for it. But what matters isn't the certainty. It's the awareness, the recognition that we're part of something larger, something that moves and changes and occasionally disrupts everything built on its surface. Not to destroy, but just because that's what planets do, what systems do, what time does, and if that's unsettling, if the idea that everything we know could be reset makes the future feel uncertain, then maybe that's not a bad thing. Maybe certainty was always an illusion. Maybe the real courage is living without it, building anyway, loving anyway, wondering anyway, knowing that nothing is guaranteed but doing it because it matters now, in this moment, regardless of how long it lasts. Our ancestors survived the last reset. They watched the ice melt and the seas rise and the climate lurch from one state to another. They lost their homes, their hunting grounds, maybe entire ways of life. But they adapted, they moved, they found new paths, and they passed something forward. The spark that became us, the consciousness that's here now, wondering about them, grateful for their resilience. And someday, if the cycle continues, someone else might do the same for us, might dig through layers of sediment or ice and find traces, might wonder what we knew, what we built, what we dreamed about, might ask if we saw it coming, if we prepared, if we understood that stability was temporary and acted accordingly, or if we assumed, like so many civilizations before us, that the world we knew would last forever. We don't know how they'll answer those questions. We don't even know if they'll exist to ask them. But we're here now, and that's what we can work with. This moment, this awareness, this chance to pay attention, to be curious, to sit with mystery instead of needing to solve everything immediately. Sleep, in a way, is like a reset. Every night we let go, we drift into unconsciousness, and every morning we return, changed slightly, renewed, the world still here. Still turning, still full of questions we haven't asked yet and patterns we haven't noticed, and maybe that daily cycle, that rhythm of release and return, is practice for the larger cycles. The ones that operate on scales we can't directly experience but can imagine, can wonder about, can prepare for in small ways. So rest now. Let the weight of deep time and ancient ice and distant catastrophes fade into the background. Let your breathing slow. Let your thoughts drift. You don't need to hold on to any of this. The cycles will turn whether you're thinking about them or not. The planet will continue its long dance through space and time, and you, right now, are exactly where you need to be. Here, present, part of it all. The resets, if they come, will come. But tonight, there's just this, the quiet, the dark, the gentle pull of sleep, and the knowledge that whatever happens, whatever changes, there's something that persists. Not in form, but in essence. The fact that awareness exists at all, that the universe found a way, through matter and time and countless trials, to look at itself, to wonder, to be, and you're part of that. Part of the long story of consciousness emerging, persisting, adapting. Part of the pattern that's been repeating for longer than we can fully grasp. And whatever comes next, you were here, you wondered, you listened, you participated. That's not nothing, that's everything. Sweet dreams, and thank you for being here, for listening, for caring enough to ask what if. That curiosity, that willingness to sit with mystery, that's what makes us human, what makes us conscious, what makes us, however briefly, awake.